Welcome to this another stream, and today I plan to cover Solana ecosystem. If you do not already know, Solana is a blockchain network, and primarily we are going to use Rust as well as TypeScript um, in order to build smart contract on Solana. So what I have thought about is to go through this Figment uh, path and Solana path, and it covers certain elements of Solana that are basic to Solana, and this will get it started. So it seems that it requires React, I guess, for the UI, Rust for writing the contracts, as well as Next.js. So we'll see what we need and why we need. I don't think we require these technologies at this point of time, but for starters, let's get started. Oh, it says that we no longer host the pathway pages on this website. The content has moved to some repository, so it seems that they have moved to GitHub at this particular point. Let's see. Oh, okay. Anyways, so for less experienced developer who wants to dive in without complicated setup, we recommend using Gitbot. So I guess it's better instead of fighting with all sorts of version dependencies and different dependencies that are required for get us going. It's best to have this Gitbot, not GitOp. So it's initializing. Meanwhile, we'll continue. So if you're an experienced developer, you can also go and clone this. So Solana is an open source. I'll just increase the font. So Solana Foundation, whatever, permissionless blockchain. And one thing is it uses proof of stake consensus algorithm. Right now, I'm not going deep inside this, but there are multiple videos talking about POS, POH, and all those things. Solana features a new timestamp system called proof of history that enables automatically ordered transaction. Right, so there are two things, POH and proof of stake as well. I guess this proof of stake will be helpful whenever we want to have some voting mechanism or which validator choose to mint the block. I guess whoever has the largest stake has higher priority, something like that. So additionally, it has low transaction costs. We already know that Ethereum and other blockchains right now are struggling with high gas fees. So Solana says that it has a low transaction cost and supports for all LLVM compatible smart contract languages. All right, what you can build, like every other Web3, NFT, any decentralized app, social app, games. I'm not sure how games are going to directly build on this one. Only thing that we can have are certain in-app purchases. So all those gaming related tokens, you can have minted those as NFTs, and those are available in your blockchain for any sort of validation. So transaction fees says that slow, high speed, supported Rust, but again C and C++, is not EVM compatible, but it offers a bidirectional token bridge between Solana and Ethereum. So project can move tokenized assets. Okay, so if you have a token that is minted on Solana, by default, there is no way you can move it from one Solana or one blockchain to another. So it says that not directly compatible, but there are multiple bridges that help you to achieve that. Yeah, one is wormhole. Okay, meanwhile, our Git pod is also initialized. Learn the web 3 stack by Figment, Solana. Meanwhile, on the terminal, it says that this is the next dev. I guess this is just for this UI that we are seeing on our system, and it is still compiling everything. Anyways, I'm also new to this, so I'm also exploring, right? So let's go ahead. Introduction to Solana. So there is a YouTube video. Again, I guess it will be repeating same thing, so we'll just skip past this. Meanwhile, I guess we can check out this video. Let's see what it says.
Hello and welcome. In this video, we'll be going over some of Solana's core technological concepts, so you can kickstart your development, become a power user, or just expand your blockchain knowledge. Introducing Solana, an open source project implementing a new, permissionless, state-of-the-art blockchain that is able to achieve a very high number of transactions per second. This is achieved by, first of all, using Solana's own consensus algorithm, named Proof of History. It can be implemented using a mechanism that has existed in Bitcoin's source code since day one, called nLockTime, that postdates transactions using block height instead of the usual timestamp. Block height, or the amount of blocks before the current one, turns out to be a cryptographically secure way to say time has passed. Solana uses a far more granular function called SHA-256 hashchain to checkpoint the ledger and coordinate consensus. Once nodes are able to trust time, decades of distributed systems research become applicable to the blockchain technology. First proposed in 1981, a technique named optimistic concurrency control enables a database to also replicate itself and maintain high availability without significantly compromising its transaction rate. The Solana project demonstrates that this technique can be efficiently applied to the blockchain on an adversarial network with a theoretical limit of more than 700,000 transactions per second. And this is on a standard gigabit network. In a 40 gigabit one, more than 28 million transactions per second can be theoretically achieved. Solana's architecture goes on to satisfy all three desirable properties of a blockchain. It is scalable, secure, and decentralized, also supporting safe, concurrent execution of programs in programming languages such as C or Rust. Now that you know what the Solana project is all about, let's delve into its core practical principles. A Solana cluster can be defined as a set of independently owned computers working together or against one another to verify the output of untrusted user-submitted programs. From the outside, the cluster can be viewed as a single system and utilized anytime a user wants to preserve or interpret an immutable record of events, such as tracking which computers did meaningful work to maintain the network or verifying possession of real-world assets. During any of these processes, the cluster produces a record of events called the ledger, which will be preserved for the lifetime of the cluster. As long as a node has a copy of the ledger, the output of its programs are reproducible, regardless of when or who deployed them. Sol is the name of Solana's native token, which can be passed down to nodes in exchange for running on-chain programs or validating their outputs. A sol is subdivisible by up to a billion times, and a billionth of a sol is called a Lamport, named after the Turing Award-winning computer scientist Leslie of their outputs. A sol is subdivisible by up to a billion times, and a billionth of a sol is called a Lamport, named after the Turing Award-winning computer scientist Leslie Lamport, Solana's biggest technical influence. As a Solana developer, you can subdivide your program into two parts: a set of decentralized, blockchain-based programs that run behind curtains and can be audited, and then there's the web app itself that interacts with your users. The basic production flow of a Solana app goes something like this. First of all, developers deploy their decentralized code app to interact with the Solana runtime is in charge of correctly passing down those instructions to our previously deployed programs. An instruction can be, for instance, transferring 1,000 Lamports between accounts given a condition is met. Instructions are then executed sequentially and atomically for each transaction. That is, if every instruction checks out, changes are committed and your program has successfully been executed. Now, if any single one of the instructions is invalid, all account changes in the transaction are completely discarded and the state of execution goes back to how it was before. So this is going to wrap up our Solana Core Concepts video. I really hope you managed to conceptualize what was presented here.
Yeah, I guess it was repetition of most of the things we talked about. The only thing is, it also talked about as smallest unit in Solana. It's also known as Lampert. Also talked about proof of history. Right, so let's move on. So as I already mentioned, we are using Gitbot where our setup is. Okay. So here are some instructions. So you can do a yarn dev and it starts a local development server. Many of the individual steps, so whatever. Let's see, go ahead using the, oh, all right. Well, just repeat it, connect to Solana. Nothing else. Oh, it seems that they have moved everything here, so we'll better stick to this one. Solana. So you click Solana pathway. Where's our kit? Oh, okay, it's already here. Let's close this. Can we expand this? Ah, nice. So Solana. Okay. I'll just zoom it a bit. Each setup in the covers a different aspect of using a particular blockchain or protocol. The format is easy to follow with the instruction on the left side and the right side. For you to interact with your code, remember that the left side can be scrolled down to show rest of the content. After some explanation of each topic, there is a coding challenge for you to complete before you can proceed to the next step, so that's good. Alright, so let's set up our project. You need to install Solana CLI. I guess in our Gitpod it's already installed. Okay, so there are some issues with Windows users, so I'll skip past this because this is not meant for us. If you wish to make use of pathway containing Data Hub, you will need a Data Hub account. Okay, I don't need Data Hub. Okay, there is some way to. So connect to Solana. We are going to interact with the Solana blockchain using Web3.js. It's a convenient way to interfere with RPC API when building JavaScript application. Under the hood, it implements Solana's RPC method and exposes them as a JavaScript object. We will explore it together as we add features to our apps. You can choose which cluster to connect to using the drop-down located in the top right. Okay, we can either use DevNet or LocalNet. If you are using a test validator for the pathway, we can connect to DevNet. All right. So we have in our challenge here. In Pages API, implement connect by creating a connection instance and getting the API version. You can replace the instance or define with the working code to accomplish. So take a few minutes to figure this out. Need some help creating. Okay, let's see how to create a connection. So I guess this is what is a client, and we are going to connect to a Solana cluster. So I guess this is the connection instance for the same. So let's go to our Gitpod. What was the path? Pages. So let's go here. Pages API Solana. Pages API Solana. And what connect? Yes, there. Now what it's saying. Connection is undefined, version is undefined, so we have to connection string constructor new connection endpoint commitment config or connection config. So let's see, new connection, what is this? This new connection, yeah, endpoint. So what will be the endpoint? Okay, that will be URL, I guess. And next one is, I guess, I guess that's not required. Yeah, second one is optional connection config. So I'll just skip past it. So it's not used, we'll see later on. And next one is version, getting the API version as well. So we have a simple get version. So let's call simple get version. Get version. Should be there in Solana. Quick fix. Let's see what it's suggesting. Oh, it's not this one. So, is it correct? Get version, define in source connection, promise is the not version. Let's see. Get version. I guess it'll be a wait here. See if it doesn't have a get version. It has a get node. They should also give some example here, but it says that we do not have a get version somehow here. Okay. Get version. Why? Maybe I have to do get version here. It's not there. Maybe inside this get versions available. It's not available in here. Where is this get version? Oh, it's there in Solana Web3 JS. No, I guess it's connection dot Get version. Oh, stupid. All right, so we got the version. So I guess instead of this one, I would just send the version. No. Okay, that's fine, I guess. Oh, it's a map. Anyway, so I guess we are done. So the solution. Okay, yeah, I have to add the await because that returns a promise. So let's add an await because that returns. Oh, that's why it was also showing some warnings here. Once you may say, click on the blue power icon button on the right side of the screen to connect and display the correct version. Okay, what does that even mean, blue? Okay. We're going to use this connection string every time we need to connect to Solana. Now we're going to want to move some tokens around, but first we need an account to hold tokens. That's what we'll do, and create a pair, again key value pair, or sorry, public private key pair and Solana so that we can have an account. Okay. So implement key pair and pass the key pair to extract the address as a string. You must replace the instance of undefined with working code to accomplish this. Key pair. Pages, key pair, sorry, pages, Solana, key pair, undefined. Let's see, generate a key pair. Again, it's a new key pair. This one is optional, so we can just do a new key pair and set new key pair. All right. The address will be key pair dot, I guess, something. Key pair dot address. What is the address? Let's see how we are going to get the address. You must replace and define working code to accomplish. Key pair is there. How to get the address? Secret is there. What is it? Key pair address. Maybe just generate. There's the public key. To create an account, a client generates a key pair which has a public key or address. Oh, public key is nothing but the address. So get just the public key, get public key. So let's keep it dot get public key or just the public key. Public key. Public key. Okay. Public key for this key, but this is not called because it is get access. Did you mean it without, or public has no method call? Are we calling this anywhere else? It's a string, okay. Dot. So the to string. No. gotcha. Okay. Oh, I thought it was a function. Well, it's automatically I can't. Alright, so we have get public key. I guess this is done. Let's see. Key pair generated. Okay, it is already here. It's generated. Solution, let's see. Address key pair public key dot to string. Okay, so that's an optional operator. From will be useful to send it back to the client side in usual format. We need to return. Okay, from and again JSON.stringify. Okay, this works, and already we have public key pair created. Okay, with same protocol, different networks have different token names. For example, with Polkadot, the mainnet token is dot and the testnet is WND. In the Solana world, the token is always called sol, so that's fine. So we are going to airdrop. One sol is equals to how many? Okay, whatever number is there is equals to that many lamberts. Okay, so we are going to request some Solana pages API Solana fund.ts. Fund.ts is our next stop, and here we are going to URL is already there. Public key we already got, right? Create a public key from string. New public key. Whatever. Public key we already did there, so are we again going to create the public key? Because I thought that's the public key. Oh, new public key. New public key. For our base 58 encoded string, I guess I need to just copy this. This should be okay, I guess. Yeah. Hash. Now next will be hash. Byte to string. No hash here. What will be the hash? Leave it. What is this hash? Okay, let's see. Connection, that is also correct. Hash request airdrop. Okay. What is this final await? I guess this is going to execute here. What is this hash? Oh, okay. That was correct. Next is we have to just confirm the transaction. So we were just correct. I'll just copy it. 1 second. I'll just so connection dot request airdrop, and then it's confirm public key. Oh, sorry, hash. So first we have connection, address, signature is my address, and it will, whatever transaction took place, it will return its address, and we will, using that, we will again confirm whether our transaction was successful or not. Yeah. What happens to this public key? My address. So this is the public key. I guess it was the address itself. Well, I guess this is already using the address here. So I do not have to. Where is this network getting used? Okay. So address will be in this one. Everything is now looks good. So let's see. Okay, that's nice. So let's also check the solution confirmed. We created a public key from my address and then use that public key to request lamports, 1 lamport or 1 sol. And then we are also checking whether our transaction is done or not. If transaction is done, we are just simply calling that. Let's see also Solana Explorer. This will give details of our transaction. It is finalized slot. So now we have 1 sol in our account. It looks good. So next, click on the check balance. Unable to check the balance. Account not funded yet. But says it's funded. There is some other issue. Okay. It says that I need to complete the balance.ts. Let's check balance.ts. Network confirmed. Public key. Just copy this public key. So I know how to get the balance now. Get balances here. So I have to find get balance. Get balance is in the connection. Dot get balance will pass public key. Right. and it will be await, I guess, because that returns a promise. Alright, so this looks good now. Let's try to do the check balance. Yeah, good. Transfer some values to another account. We need to create and send a signature transaction to the cluster. Once you understand how to do that, we need to send a signed transaction to a cluster. You will have solid foundation on which to interact with portion of the Solana layer. When a transaction is submitted to the cluster, the Solana runtime will execute a program to process each of the instruction contained in the transaction that we already talked about. Any fails and it will reward. When you're transferring Lamport, make sure to begin with 0. So for example, 0.2 the device transaction will give you an error. Finish now transfer.ts in this one. Alright, I guess we have done till funding our account, and after that for the transfer of Solana or the Lamperts from one account to another account, let's do that in another video. Alright, so thank you for joining in for this video. I guess this was helpful and get you going with Solana blockchain.